Hello everyone. Today we will discuss about the differentiability of a function. We will start from what is the meaning of differentiability of a function. Then we will try to understand it by the help of geometrical meaning, and then how to prove a function to be differentiable at given point. So let us start. What is the meaning of differentiability of a function? Differentiability of a function meaning that given function is differentiable at all its points of domain. So let fx be a function and it is differentiable at all points of its domain. We will discuss this later on. Fx, it is a differentiable at all points of its domain. Then we can say the given function is a differentiable function. Then fx is a differentiable function. Differentiable function means we can find the derivative or d dx of f. So differentiable means we can get dy by dx if y equals to fx, or f dash x means derivative of f. All these are same things. A function is said to be differentiable if it is differentiable at all its points of domain. Now let us go to discuss what is the meaning of differentiability of a function at a given point. Now let us go to define the differentiability of a function at a given point. So differentiability of fx given function at a point. So here for that let fx be a real valued function and a point C belongs to open interval AB which is the subset of that domain belongs to AB. Then f is said to be, then f function is said to be differentiable means its derivative exists at that point if and only if this limit x tends to c, f of x minus f of c upon x minus c exists finitely. This point is very important. This limit exists and that limit must be finite. Okay, we will now discuss this point from here. So up to here we have discussed that what is the meaning of differentiability of a function at a given point. And if this limit exists finitely, then given function is a differentiable at point C. And if given function is a differentiable at point C, then we can write this because of if and only if. Okay. Now let us go to discuss this in detail. as we have discussed the differentiability of a function at a given point. So for that, fx is differentiable at x equals to c belongs to open interval AB. AB is a part of that domain if and only if this limit x tends to c f of x minus f of c upon x minus c exists finitely. Okay, now what is the meaning of existence of a limit? That means its LHL left hand limit and its RHL right hand limit both must be equal. So let us write its LHL. That is LHL, we are coming from the left hand side of the point C. Let us see, we are coming from this side, means this part is C negative and this part is C positive. So we will take a small neighborhood just adjacent of this point C minus H and C plus H. In this neighborhood we will discuss. So let us write LHL left hand limit x tends to C negative f of x minus f of c upon x minus c equals to, what is the RHL? Limit x tends to c positive f of x minus f of c upon x minus c. Now let us simplify this one. Here I am going to take x equals to c minus h, and in this part I am going to take x equals to c plus h. Okay, so if h tends to 0, so x tends to c. Here the similar case, h tends to 0, then x tends to c. Okay, replace it. Now LHL becomes limit h tends to 0 f of, in place of x I am going to put c minus h minus f of c upon x minus c. If you see here, x minus c will be, you send this side, will be minus h. And what is the right hand limit? Limit s tends to 0, I am going to replace x by c plus h. So f of c plus h minus f of c divided by x minus. Okay, here it comes. I have written this part, f limit s tends to 0 f of c minus h minus f of c upon minus h. This part is called LHD or left hand derivative. Sometimes we show it by LF dash x. Okay, and this part is called RHD, right hand limit, right hand derivative, and we show it RF dash x. When left hand derivative and right hand derivative are equal and finite, this is the important, finite, this limit must be finite, then the derivative of that function exists at that point, means point is here c, at that point c, or we can say that function is differentiable at that point. If the derivative exists, it means function is differentiable at that point. That means what? Differentiable means we can find the f dash x at that point. Here it is the same as you remember the first principle. So this one is the same as we can represent is f dash x. So f dash x is nothing but it is f dash x equals to limit s tends to 0. Any side you can write, from both sides you will get the same. Since here I have taken f dash x, so in place of point C I will take x plus h minus f of x upon h. If we are interested in f dash c means the derivative of the function at point c. So I have to write in this way: s tends to 0, f of c plus h minus f of c upon h. A function is said to be differentiable if it is differentiable at every point of its domain, and a function is differentiable at a point means its left hand derivative and right hand derivative equal and finite. Its value is finite. Okay, now let us try to understand what is the meaning of a differentiable derivative at a point of a function geometrically. I have a function, modulus function. Okay, modulus function. This is very popular function, as you know, which is defined as mod x if x greater than or equals to 0 and minus x if x less than 0. If we see the graph of this function is this one. Okay, x dash y dash, this one is a origin. This modulus function is differentiable except the point at x equals to 0. Mod x is not differentiable at x equals to 0. How can we say? Just by seeing the graph, we can say if there is any corner point. So at that corner point, the function will be not differentiable. Why? Because the differentiability dy by dx or f dash x related with the tangent, and it is what? Slope of the tangent. Slope of tangent. So if we discuss the slope of the tangent at point 0 means origin, how many tangents are possible? Here we can draw infinite tangents. Means we are not able to find out the unique tangent. So the meaning of a differentiability at a point, its geometrical meaning, geometrically we can have unique tangent at that point. Not can have, we will have. We will have unique tangent at that point. If we are not able to have a unique tangent at that point, it means that function is not differentiable at that point. So, as we know that at the corner point, there will be no unique tangent. So the function will be not differentiable at corner points. So you can see it is a corner point. So here the function will be not differentiable. I will prove it theoretically also. Let us prove theoretically. So for this I have to find out LHT, left hand derivative. What was that? Limit s tends to 0, f of c minus h minus f of c divided by minus h. Here c is what? Here c is 0.0. We are going to discuss the point origin. So let us put it here. Limit s tends to 0, f of 0 minus h minus f of 0 upon minus h. Now let us put it 0 minus h. For 0 minus h, the function will be in this way, or you can put in this way: 0 minus h minus mod 0 upon minus h. So here you will have limit s tends to 0. This will h minus 0 upon minus h. So what will be the limit of left hand derivative? Minus 1. Now let us find out right hand derivative. RHD. For that, limit h tends to 0, f of 0 plus h minus f of 0 upon h. Limit h tends to 0, mod of 0 plus h minus mod of 0 divided by h. Limit s tends to 0, this will give you h minus 0 upon h, and this will give you right hand limit, right hand derivative as a 1. Here left hand derivative is not equal to right hand derivative. So given function mod x is not differentiable at x equals to 0. So mod x is not differentiable at x equals to 0, which we have already concluded that because there is a corner point. What may be the other reason of not differentiability? There may be one more reason, that function is not continuous at that point, means function is broken there. So at that point also the given function is not differentiable. Okay, every differentiable function is continuous. This is the very important point. Every differentiable function is a continuous, but the converse is not true. So let us discuss this one. If I consider f of x minus f of c, so I can write for x not equals to c, I can write f of x minus f of c divided by x minus c into x minus c. This part I am going to write because there will be no effect. Okay, now taking the limit of both sides. So limit x tends to c, f of x minus f of c, limit x tends to c, f of x minus f of c divided by x minus c, x minus c, limit of all sides. Now using the algebra of the limit x tends to c fx distributed minus limit x tends to c f of c, limit x tends to c f of x minus f of c divided by x minus c into limit x tends to c x minus c. Now see, this one is limit x tends to c f of x, this will change to minus f of c, and this is what? If you remember, this one is the our f dash x or f dash c. Here f dash c, derivative of a function at point c, first one, into this one is what? 0. If I put c in place of x, it becomes 0. So this side becomes 0. Now we can write limit x tends to c fx equals to f of c, sending that side, which is the condition for the continuity of a function. That means implies that fx is continuous at x equals to c. We have taken what? This is defined, so let fx is differentiable at x equals to c. That means this exists. In place of this I have written this, and we have concluded that fx is continuous at x equals to c, but its converse is not true. So we have discussed that a function is differentiable, a function is differentiable means what? Its derivative exists. Okay, when it will be differentiable? If function is differentiable at each point of its domain okay. Function differentiable at a point means x equals to say if and only if LHD equals to, or you can say limit x tends to c f of x minus f of c upon x minus c exists finitely. Okay, when it is exist, when its left hand limit and right hand limit will be equal and finite. So what will be its left hand limit and right hand limit? LHD and RHD must be equal and it must be finite. What is the LHD? LHD is limit s tends to 0 f of c minus h minus f of c upon minus h equals to limit s tends to 0 f of c plus h minus f of c upon h. So these are the some concepts related to the differentiability of a function at a point or a differentiability of a function. Thank you.